A square prism of base side 30 millimeter and height 75 millimeter rests on the HP on one of its ends with two of its rectangular faces equally inclined to the VP. It is cut by a plane perpendicular to the VP and inclined at 60 degree to the HP, meeting the axis at 15 millimeter from the top. Draw the elevation, sectional plan and true shape of the section. What are the maximum width W and the length of the section? So this is the case of a square prism. And again, the dimensions are given. The base side is 30 millimeter and the height is 75 millimeter. It is resting on HP on one of its ends with two of its rectangular faces equally inclined to the VP. So this case we have already seen, that is when two of its rectangular faces, how it can be equally inclined to the VP. In the top view, all the edges of the square will be equally inclined to the XY line, that is 45 degree inclined to the XY line. So that is the condition. So now it is cut by a plane perpendicular to the VP. So it is perpendicular to the VP. So obviously the section plane will be in the front view and inclined at a 60 degree to the HP. So there is some inclination with the HP. In the previous two cases, there were no inclination with the HP or the VP, but it was perpendicular to one of the plane and parallel to the other. So the true shape of the section was obviously in that either in the front view or in the top view, it was already there. So you don't have to draw the true shape of the section separately. But here, since there is some inclination with HP and the section plane is perpendicular to VP, the true shape of the section and the apparent shape of the section will be different. So so in this case, the axis is inclined at 60 degree to the HP, meeting the axis at 15 millimeter from the top. So the section plane is meeting the axis at a distance 15 millimeter from the top of the square prism. So now what we have to do is we have to draw the elevation, the sectional plan and the true shape of the section. So all these three things we have to find out. Then what are the maximum width and maximum length of the section? So now let's see how it is being drawn. So now the XY line, so it is drawn towards the left side because we want to draw the true shape also. So we need some space towards the right. So this is how this will be drawn, the XY line. Then the square is drawn in such a way that the inclination of its edges with the XY will be 45 degree. So this inclination is 45 degree. So otherwise, that is how the equal inclination can be shown in the top view. So this is 45 degree. On the opposite side also it is 45 degree. The other two faces also are of 45 degree each. So this is how it is being drawn. Now the front view. Front view with the axis length of 75 millimeter. Then the points, all the points A1, B2, C3 and D4 in the top view, A dash, B dash, C dash and D dash in the front view, and as well as 1 dash, 2 dash, 3 dash and 4 dash, out of which D dash and 4 dash is in the back. See, D4 is in the back, so D dash and 4 dash will be the invisible edge which we cannot see actually. Since it is behind this BD, we doesn't have to draw it as dotted line because BD is anyway a continuous line. So even if we draw a dotted line as D4, the D4 as dotted line, it doesn't create any sense. So now the condition is 15 millimeter below the top. You have to mark a point. 15 millimeter below the top, you have to mark a point. This is the point through which the section plane will be passing. And now the section plane is making an angle of 60 degree with the horizontal plane. So we draw a line which is making an angle of 60 degree with this one. That is, this angle is 60 degree. This angle is 60 degree. So that might be there. So that angle is 60 degree. So likewise, you like this, you draw the section plane, and this part is removed. This is the vertical raise. Since it is in the front view, it is the vertical raise. So this part is the part above this particular section plane is removed. So then the newly generated coordinates. Here there will be two coordinates generated, P as well as Q. P in the front and Q in the back. PQ. And here there will be two coordinates generated, one here and one in the back, one in B2 and the second one in D4. So two coordinates will be generated here. So that is marked as R and S. Then another corner, a single corner here at the T. So there will be all of a total of 5 coordinates will be newly generated. Newly generated 5 coordinates will be there. Now from these 5 coordinates, there will be actually two pairs and a single one. So from this P and Q doesn't fall on any vertical edges. So from P and Q, you have to draw the vertical projector, and in the top view, you have to mark the P dash and Q. I mean P and Q. So P dash is in the front and Q dash is in the back. So P will be here and Q will be here. So P there and the Q is here. Now R and S in the corresponding vertical edges. R will be in the vertical edge B2 and S will be in the vertical edge D4. So then P in the vertical edge C3. So all the 5 points are marked in the top view. Now you have to mark the top view. So this is the sectioned surface. This is the sectioned surface in top view. Only this much. A shape of a pentagonal shape, not a regular pentagon, but a pentagonal shape in the top view. And in the front view, only this much portion remains. So in the top view, this portion also remains there. This portion also remains there, but it is an unsectioned surface. This is not a sectioned surface, so it remains unhatched. So this is it. Now how to draw the true shape? Now to draw the true shape, what you have to do is, you have to draw perpendicular to this section plane, perpendicular to this section plane from all these 5 points, from P dash, Q dash, from R dash, S dash, from T dash. You draw perpendicular lines to this particular section plane. Like this. These 3 lines. These 3 lines are perpendicular lines to the section plane. Now you create a parallel line, a line which is parallel to this section plane at some distance. The distance between these 2 lines are not important, but it should be sufficiently distant, not too close and not too far. If it is too far, then you may not be able to draw it completely. So if it should not cross with this one, it is better. It is always better it doesn't cross with this one. Even if it crosses, it is okay, but it is always better it doesn't cross with the front view. This X1, Y1 line. This X1, Y1 line is parallel to this section surface, or this X1, Y1 line is perpendicular to this newly drawn projectors. Newly drawn projectors from P dash, Q dash, R dash, S dash, and T dash. Now is the difficult part. In order to mark this point P and Q in the true shape, the distance of P is the distance from this point to this point. That is the point Q, sorry. In order to mark the point Q, the distance between the XY line and the top view of Q, this distance is taken here, and that particular distance is marked here. So that is point Q. And in the true shape, the letters, the naming of the letters is using the capital letters itself. So in order to mark Q, from the projector through the Q, from x1 y1 line, distance equal to the distance of q, small letter q in the top view from xy line is taken. That is this much distance. The distance from here, this point to this point. So that distance is marked. This distance is taken and that distance is marked here. So that is q. And now in order to mark the point P, so P dash Q dash has the same projector. So in that case, the distance of P from XY line. So XY line is this line. So from this line, that is from this point to this point, the distance is taken and that particular distance is marked here. So that is P. Now PQ as already marked. Now S. In order to mark S, the projector through S is through S dash is this one, R dash S dash. That is this line. This line is the projector through R dash S dash. So the distance of S from XY line, that is this distance. This distance is taken and that particular distance is marked here. This distance is taken and that particular distance is marked here. And to R, the distance from XY to the point R, this distance. That distance is taken and that distance is marked in the projector through R dash S dash. So PQR S are marked. Now in order to mark T, in the projector through T, from the line x1 y1, from the line x1 y1, the distance of T in the top view from xy line, that is this distance. This distance is marked here. That distance is marked here and that is the point T. Now join P, Q, R, S and T and then give a section, the section lines also. And this is how the true shape of the section is drawn. I'll explain once more. First you draw the XY line and with the XY line you draw the top view, which makes an angle of the edges of the top view will be making an angle of 45 degrees with each other. Then the front view, then 15 millimeter below the top face you mark a point and through that point making an angle of 60 degrees you draw a line which is the section line, section plane actually. So then VT is marked, then the newly generated edges are marked, P dash, Q dash, R dash, S dash and the T dash, and those newly generated edges are marked in the top view also. Then the top view, the section, the surface in the top view is completed. Then the front view is completed. Then the top view, the completion of the top view is done. See here, the completion of the top view is done. Then from the newly in the front view, from the newly generated points, draw 3 perpendicular lines to the section plane, and a line which is parallel to the section plane also at a distance, at a sufficiently large distance, and it is not too close as well as too far away. It is as close, it is better, it is as close as to the front view. It is very much close to the front view, but it should not be too far from the front view. So now in this projector lines from x1 y1 mark the point Q in such a way that the distance of x1 y1 to Q is the capital Q. X1 y1 to capital Q is the distance from x y to small q. The distance of xy to small q is taken as this distance. Now the same distance in the distance of p, small letter p in the top view from xy line is taken, and that distance is taken in the from the x1 y1 line to this point p. Likewise, you mark the point S, R, and T. Now join P, Q, R, S, and T. Now the section the surface. Now the section the lines also. Okay. Is it okay?
Sir.
Yeah.
PQRS point is
ഓക്കെ, ഈ പോയിന്റ് ക്യൂ എന്ന് പറയുന്ന പോയിന്റ് കിട്ടാൻ വേണ്ടിയിട്ട്, ഇവിടുത്തെ ക്യൂ എന്ന് പറയുന്ന പോയിന്റ് കിട്ടാൻ വേണ്ടി ഇവിടെ എക്സ് വൈ ലൈനിൽ നിന്ന് ക്യൂവിലേക്കുള്ള ഡിസ്റ്റൻസ് എടുക്കുക. ഈ എക്സ് വൈ ലൈനിൽ നിന്ന് ക്യൂവിലേക്കുള്ള ഈ ഡിസ്റ്റൻസ് എടുക്കുക. ആ ഡിസ്റ്റൻസ് ഈ പി ക്യൂവിലൂടെയുള്ള, ഇവിടെ ക്യൂവിലൂടെയുള്ള പ്രൊജക്ടർ ഉണ്ടല്ലോ, ആ പ്രൊജക്ടറിൽ മാർക്ക് ചെയ്യുക. ആ പ്രൊജക്ടറിൽ x1 y1 ലൈനിൽ നിന്ന്, അതെപ്പോഴും ശ്രദ്ധിക്കണം, x1 y1 ലൈനിൽ നിന്നാണ് മാർക്ക് ചെയ്യുന്നത്. ഒരു കോമൺ മിസ്റ്റേക്ക് എന്ന് പറയുന്നത് അതെപ്പോഴും പി ക്യൂ എന്ന് പറയുന്ന ഈ പോയിന്റിൽ നിന്ന്, ഈ സെക്ഷൻ്റെ സർഫസിൽ നിന്ന് തന്നെ മാർക്ക് ചെയ്യും. സോ ദാറ്റ് ഈസ് എ കോമൺ മിസ്റ്റേക്ക്. സോ അത് നിങ്ങൾ എപ്പോഴും ശ്രദ്ധിക്കണം. x1 y1 എന്ന് പറയുന്ന ലൈനിൽ നിന്നാണ് ക്യൂ എന്ന് പറയുന്ന ഈ ഡിസ്റ്റൻസ് മാർക്ക് ചെയ്യേണ്ടത്. ക്യൂവിലേക്കുള്ള ഈ ഡിസ്റ്റൻസ് ഇവിടെ നിന്ന്, ഈ XY ലൈനിൽ നിന്ന് ക്യൂവിലേക്കുള്ള ഈ ഡിസ്റ്റൻസ് ആണ് ഈ പോയിന്റിൽ നിന്ന് x1 y1 ലൈനിൽ നിന്ന് ക്യൂവിലേക്കുള്ള ഡിസ്റ്റൻസ്, ക്യാപിറ്റൽ ക്യൂവിലേക്കുള്ള ഡിസ്റ്റൻസ്. പിയിലേക്കുള്ള ഡിസ്റ്റൻസ് XY ലൈനിൽ നിന്ന് സ്മോൾ പി, ടോപ്പ് വ്യൂവിലെ പിയിലേക്കുള്ള ഡിസ്റ്റൻസ് ആണ് x1 y1 നിന്ന് ക്യാപിറ്റൽ പിയിലേക്കുള്ളത്. ഓക്കെ, ക്ലിയർ ആയോ?
ഈ x1 y1 എന്താ സംഭവം?
x1 y1 എന്ന് പറയുന്നത് നമ്മൾ ഈ വെർട്ടിക്കൽ ട്രേസിന്, അതായത് നമ്മുടെ സെക്ഷൻ പ്ലെയിനിന് പാരലൽ ആയിട്ട് ഒരു ലൈനോട് അഡീഷണൽ ഒരു പ്ലെയിൻ നമ്മൾ ക്രിയേറ്റ് ചെയ്യുന്നതേ ഉള്ളൂ, ഒരു ലൈൻ. അവിടെ നിന്ന് അതിനെ ബേസ് ആക്കിക്കൊണ്ട് നമുക്ക് ഈ ഡിസ്റ്റൻസസ് മാർക്ക് ചെയ്യാൻ വേണ്ടിയിട്ട് ആ സ്പെസിഫിക് മീനിങ്.
ഓക്കെ സർ.
ഈ ഡിസ്റ്റൻസ് നമുക്ക് മാർക്ക് ചെയ്യാൻ വേണ്ടിയിട്ട് ഒരു ബേസ് വേണം. ഈ XY ലൈനിൽ നിന്ന് നമുക്ക് ഈ ഡിസ്റ്റൻസ് മാർക്ക് ചെയ്യാൻ വേണ്ടിയിട്ടൊരു ഒരു ഡേറ്റം വേണം. അതിനു വേണ്ടിയിട്ടാണ് നമ്മൾ x1 y1 എടുക്കുന്നത്.